Good day, everyone, and welcome. My name is Kayla Altman, and I am a Communities Coordinator at ASUG, and I am pleased to welcome you to today's webcast, Accelerating Internet of Things in Your Organization, introducing SAP's IoT Development Platform, and thank you for your participation today. I do have a few announcements as well as some housekeeping notes for you to please keep in mind during today's presentation. The first is a reminder that today's webcast will be recorded. The recording, as well as the slide deck, will be posted to the asug.com discussion forum, and we will also email that link out directly to you. I do also encourage you to access past recordings from this series by visiting that same forum on asug.com. We also have a number of events that are upcoming in the fall. The first is the SAP Analytics and Business Objects User Conference. Hosted in Austin, Texas, August 31st through September 2nd. This will be a 3-day event for business objects and analytics users. We do encourage you to visit us at sabach.asug.com to submit your registration today. Co-located with that event will be a 3-day practical analytics workshop. The 3-day hands-on analytics training course for business users. And to find out more information or to submit your registration, you can visit us on the site that is on your screen. Finally, we will be also hosting the annual Business One Summit. It's an annual event. We usually brings out about 500 Business One users. So for anyone who is a small business owner looking to run Business One or seeking to connect with other B1 users, we do encourage you to attend. For anyone who wants to be involved in ASUG's Influence Department, we are currently accepting registrations for the upcoming projects. You can register at influence.sap.com for more information. It is now with great pleasure that I turn us over to Paul Kurchina, who is the Community Advocate for the Internet of Things, and Paul will be introducing our speakers for today. Paul?
Thank you, Kayla, and welcome everyone, and welcome to the last of this episode webcast series. We started this way back on May 28th, and it wasn't that long ago, and have had a very interesting series of webcasts almost each and every week since that time. I just want to remind folks what we'll be sharing to people post the event, probably sometime in July, is actually links to a number of the blogs that have been produced in around each and every webcast in the series. So that'll be your opportunity not just to revisit some of what was discussed, but actually to potentially share this with other people in your organizations that may be interested. And we're working on figuring out, based on getting some input from attendees, what are the future topics that we want to cover. So we plan a whole series of programmings, both virtually and face-to-face to ASUG members. And I want to really highlight as well one upcoming webcast that we have on July 23rd. Will include notice of this webcast and the push out to attendees. We're very pleased to have a webcast by the Hamburg Port talking about their efforts around IoT. It's called Innovate Through IoT and Achieve Quick ROI with SAP Network Logistic Hubs. It's a great story of great business value, so I definitely encourage you to attend that webcast. And one more reminder, this webcast today, if you have any questions during the webcast, please use the chat capability that are on your screens. At the end of today's session, I will be moderating the Q&A for our speakers. So without further ado, I want to welcome both Rui and Aaron from SAP to give you some sense of an added SAP perspective around IoT and the HANA Cloud Platform. Rui and Aaron?
Thank you. Yeah, thank you very much, Paul, for the introduction. So Aaron and I are working on the product management of the HANA Cloud Platform, and we want to look into how you can accelerate IoT in your organization with SAP's IoT Development Platform. So, but before looking into the IoT topic itself, let's first look into the reasons why this topic has become so relevant, that many large companies in various industries are already today investing heavily into leveraging such IoT scenarios. So today we are in the area that will start the fourth economic revolution. So each of these revolutions you see here on the slide has created a significant increase in the gross world product. So in the 1815s we had steam engines, textile manufacturing and gas lighting creating a shift in the business operations to mass production and really broad distribution of goods. In the 1970s, we had process automation, which started and led to the centralized factory controls, and we got the first knowledge workers. And with the rise of the internet economy in the 1990s, the business was able to create direct connections to customers. So nowadays, many consumers have access to computers, which also helps drive additional business. And the highly available internet infrastructure we have today makes it also simple to connect all of those computers with each other. So in companies like Facebook and Google were founded and created new value streams for business. So our next shift will be what we call the networked economy. So this era will be moving the Internet of Content we've had in the 90s and the Internet of People we've seen growing in the past decade to the so-called Internet of Things. So things like cars, planes, refrigerators, light bulbs suddenly become smart by connecting them to the Internet and let them communicate with other devices. And the amount of data collected and the combination of it with data already available today in on-premise systems brings now huge potential for business. And enterprises have taken note of these technologies. So these technologies nowadays can already connect hundreds of millions of people with a relatively low effort. So that there are predictions that by 2020, the estimated global business trade will increase in the same time by 70% to $65 trillion. Really huge. At that time, we'll have around 2.5 billion people connected on social networks. So that's nearly a third of the global population. And finally, depending on who you ask, the number of devices that will be connected to the internet will increase from currently around 7 billion to something between 25 to 75 billion. But I mean, the big question behind this now is what can individuals, companies, and the society achieve when everything is really connected? When you have a bidirectional network connecting people, business, process, data, and everything together into one big thing. Well, what we can already see today, the Internet of Things will touch almost every aspect of life and business. So as an example, connected logistics can give you access to real-time information from your vehicles and cargo. So with this information, you can plan your routes, maintain your vehicles, and schedule your service personnel to improve your service offerings while driving down costs at the same time. Another example, smart cities can save millions of dollars by optimizing the energy usage. For example, when smart city lighting doesn't sense any pedestrians, it can dim the smart LED lighting system on the streets and with that reduce the energy consumption and also the costs related to that. And another on like collecting waste. You only collect the trash if the bins report that they are full and you don't collect it on a regular schedule. Also, connecting buildings will be able to use energy efficiently by, for example, combining the weather forecast with the air condition system in these buildings. So just a few examples what is really possible. And of course, I'm calling from Germany, the most important thing, connected cars. So imagine if you can combine all the possibilities of connected cars with connected cities. Your car knows your destination, and instead of driving around to find a place to park your car directs you to the nearest car park with a reserved parking slot just for you. So that would be great, at least here in Germany. But as I just said before, industries are heavily investing today into this area already. So according to some estimations, we are talking about $14.4 trillion in additional revenues by 2022. So if enterprises today do not pursue the opportunity in front of them, they will really suffer from squeezed margins because machine-to-machine communication is less costly. time-consuming and also less error-prone compared to people-to-machine communication. And companies who take advantage of these opportunities will really win against their competitors. So what should you do? Actually, 3 things. First of all, connect with your Internet-enabled things to gain new insights. And how do you do that? By combining your business data with an intelligent analysis of the data from your devices, networks, and other data sources. Secondly, transform the way you make decisions and take action. And again, how to do that? You execute operational processes through predictive and automated responses derived from the information you get from your devices and data from all your network and the business you already collected. And finally, reimagine your customer's experience. Create customer-responsive products, providing a value add by empowering innovative new business models, and also increase the loyalty of your customers with personalized products and services. So really trying to leverage all the data and all the information that you have to make it really fit 100% to what your customer needs and wants. So how will these 3 steps now work in conjunction? So easily speaking, you start connecting to devices that you have and collect the data. Then you take that data, combine it with the information you already have to date and transform it into valuable insights. And finally, take those insights and use it to reimagine your business. While doing that, you might find out that you need more information or further connectivity, being it to devices, being it maybe to other systems or other networks, and the circle starts again. But now let's take the topic now of IoT and split it up into pieces to really also come to the part where SAP comes into play. So we are, on the one hand side, talking about really things, meaning embedded sensors and physical devices that are part of the Internet of Things. And this information somehow needs to be transported and connected, right? So via the Internet, via Wi-Fi, via all kinds of channels that exist to transmit the data. And finally, you also need then some infrastructure where you collect this information and ideally in a high-performance compute infrastructure. So, and that's where now SAP comes into play. So meaning if you look into the various states of the life cycle in your company of products, the HANA Cloud Platform can now play a big role, right? So it will help you to manage your devices and also manage all the applications by using not only technology from SAP, which is you see here in orange, but also leveraging technologies provided by partners, provided by infrastructure providers, so that you can connect much more and leverage much more functionalities, not only coming from SAP, but leveraging also what partners provide to you. Which brings us now to the HANA Cloud Platform, because that's now our platform that you can use for such IoT scenarios. And to do that, let me quickly just introduce what the HANA Cloud Platform is, in case you haven't heard of it yet. So the HANA Cloud Platform is a platform as a service offering, helping you to either connect to already existing on-premise systems or systems that you are running in a managed cloud environment, like the SAP Business Suite, the Business Warehouse, S/4HANA, and also let you connect to available cloud systems that are already there, like SuccessFactors, Ariba Concur, and so on and so forth. And this platform lets you now either create completely new applications from scratch, so platform as a service, meaning a platform for developers to help them creating new applications from scratch and develop and deploy them in a efficient and scalable way into the cloud. On the other side, creating extensions for both on-premise or cloud systems. So really leaving you with the possibility to run your business in 2 speeds. So having on the current business that you have a very rock solid system, not touching it, but instead creating your innovation on top of that with the HANA Cloud Platform by creating extensions that you can use then in the cloud. And third pillar here, the integration, to use the HANA Cloud Platform also to integrate other systems into the applications you are running in the cloud. So here a picture of the architecture of the HANA Cloud Platform and some main services we provide to date. So the HANA Cloud Platform runs in various SAP data centers around the globe. So currently we have data centers in the US, in Europe, and in Australia. There is an infrastructure layer on top of that, and the HANA Cloud Platform runs on this infrastructure and provides developers with 3 runtimes, Java, JavaScript, and HTML5. And also HANA native development, of course, running on the SAP HANA platform, as well also along with Sybase ASE on the data platform side. Some core services which help you to create connectivity to on-premise and cloud systems. Functionality that helps you to also store unstructured data like documents in a content management system. Of course, very importantly, security services to enable you to authenticate and authorize your applications and also your users in the cloud, and functionality around API management. And on top of those, you have then what we call here extended services to help you create mobile applications, applications running also on the portal application. We are providing the SAP HANA Cloud Portal. Fiori as a service, also providing a means for you to develop your applications directly in the cloud with a web IDE. And then what we are talking about here in this context, of course, also the IoT services. And all of this, of course, with integrated operations that we are taking care of for our customers and partners, so that the infrastructure and the whole platform is kept up and running and highly available. Just quickly, in a nutshell, what the HANA Cloud Platform now is again. Just said, we are supporting 3 runtimes, programming languages. Either you create HANA native applications, Java applications, or HTML5 applications on what we call a standards-based development environment. So you can use Eclipse, an open source IDE and integrated development environment. And then, as I just talked about, you can store data and leverage the speed of HANA, store unstructured data with the document service that we provide. You can connect very easily your cloud applications on HANA Cloud Platform with on-premise and other cloud systems, use the federated identity management, and then use the extended services like the HANA Cloud Portal to create attractive sites, the HANA Cloud Integration, which is the PI, the process integration in the cloud, leverage the mobile capabilities of the HANA Cloud Platform mobile services, and use also the HANA Cloud Platform to build extensions to either SAP or non-SAP software and provide it in the cloud, and all of that along with enterprise service levels. And maybe also good to know, so this is already a look into what we are planning in the future. Sorry, clicked too much. We are currently contributing to the Cloud Foundry Foundation and the OpenStack Foundation, which will help us to open up also the infrastructure as a service layer that we currently use, and also enable our current architecture in a way that you can run also, that it has a Cloud Foundry architecture, and with that be able to also run HANA Cloud Platform maybe also in customer and data centers. So that's nothing that we have available right now, but as you can already see in these contributions and our engagement here, this is what our plan is, really to make the platform as open as possible for our customers and partners. So that's around the introduction to the HANA Cloud Platform, really in a nutshell. Now let's look into the IoT services on the HANA Cloud Platform. So if you're wondering who is already using that, you might have heard about the Siemens use case, who are using the HANA Cloud Platform for their solution called Cloud for Industry. So that's a large IoT scenario that Siemens is running here to provide their customers with a platform enabling the customers to really store huge amounts of data coming from sensors from all kinds of different machines in the cloud. And if you want, I also put on this sheet here the link to the press release where you find out a little bit more about how Siemens is using the HANA Cloud Platform for that. So now let's look into the IoT services that we already have now in the HANA Cloud Platform. So it enables customers and partners to develop, customize, and operate IoT business apps in the clouds. And for that, we are using the three building blocks of the IoT services we have to date. So we have the Internet of Things Service Cockpit, we have an embedded remote device management service, and message management service. And important to know that these services are currently available as a public beta, but we are planning to go globally available soon. Now let's look quickly into the architecture, how the IoT services work. So we have two roles here. If you're the administrator of your account for an IoT application, what you do, you use the Internet of Things Service Cockpit and use the remote device management service to put the devices on the HANA Cloud Platform. So you create device types and then also take care that the devices that you connect via protocols like HTTP, that they can store their sensor data in the HANA Cloud Platform. So you create automatically an API that this device can use and also send the data in a secure way via OAuth, so that only authorized devices can really store the sensor data that they have collected and put it into the HANA Cloud Platform where these sensor data are stored. And on the other way around, you can also even send messages back to your devices and have some kind of possibility to send feedback to the device, and with that also bring the possibility, for example, having a smart watch right on your wrist, and if you're in the logistics business and you're driving a truck and the truck is sending now information about where you are, that your boss tells you, come on, don't drive 100 miles per hour with your truck, that's too fast, and get it as an information on the watch, right? With using this channel from the HANA Cloud Platform back to a device. Meaning that the second role, the IoT application user, just uses then the application that you build on top of these IoT services. And the application then has access to all the information stored from the services, and combining now this with the built-in HANA platform where you can run predictive analysis, can all do the great magic that you know from HANA. You can really derive now all these benefits that we just talked about now at the beginning to take advantage of the data that we have stored and to really dig out the gold nuggets in that data, which makes then the difference in the business that you are running compared to your competitors. And now just a quick walk through the IoT cockpit. So Aaron later on will show it also in a demo how this works, but very quickly what you will see. So the cockpit is actually the place where you manage all the devices and the types of devices you have, and also the place then where you deploy the what we call here the message management service, which is the part that provides you for your devices the API to really send your data to. So and the remote device management then helps you then to register these devices, and once this device is really actually registered, it can start sending all the data to the HANA Cloud Platform in a secure and authorized way. And here is the as a last point now before the demo, the message management service, so important for the admin of the IoT application then, where the admin can actually look how messages are coming in, and also for developers a means to test out what they have clicked together before in the Internet of Things cockpit to see if the HANA Cloud Platform can store all the sensor data coming in as kind of a test. So with that said, I would like to hand over to Aaron, who will give you now a more detailed view into what the IoT services are and how you actually can start using it. Aaron, you want to take over?
Sure. Thank you, Rui. As Rui said, my name is Aaron Williams. I'm one of the product managers. I'm actually out here in Palo Alto, California, and I'll walk you through how to get going on this, how to get started, and show you. We filmed kind of like a creation of a simple application and how to get some data up into the HANA Cloud Platform via the IoT services. At the end of this, we'll have a bunch of links for you, so how you can get going and do this yourself, and go a little bit farther into some of our tutorials where you can actually hook up your own devices and see how this works for yourself. So the biggest thing right now is first thing you have to have is a HCP account. They're free. This is a fully functioning account. It's not limited by time. It is limited, as you'll see when you get there, of how many things that you can start up and whatnot. But it's not like it's a 30-day trial or anything like that. But what you do is go to account.hanatrial.ondemand.com, and we'll give you those links at the end, and it will show you how to get that free account. The next thing is that you need to do is you actually will, and I'll show this in the video in just a sec, is you actually have to, after you set it up, you'll have to actually go in and enable the services for the IoT services, so that way, and it's just one of many services that we have, so that way actually allow you to do it. And then after that, the next thing that you'll do is you'll see a page that looks like this, and you'll be able to set up your device types, your message types, and your devices. And this is how it tells the system how the communication is going to be coming across, what the ones and zeros actually mean. And from that, you'll be able to control how you can send messages. You can do it through, I'm going to be showing you just how to send messages through HTTP post. You can actually also send messages in a two-way, and you can also use WebSockets for the moment. We have a whole lot of other ways to do it coming up in our on our roadmap. Some will be released for TechEd, which is in October, at least the TechEd here in the Americas, which is in Las Vegas, Nevada. And then soon after that, we'll probably have a little bit more releases the next month for the TechEd that's in Barcelona. So what we did just to make this nice and simple is, and so that way I don't have to worry about the internet crashing while I'm talking, is we loaded up just a video of me just going through that, and when I'm going through the setup, and what I'm going to do is I'm just going to talk over it as it plays. And we'll see, and give you guys some pointers on this. All right, let's start it up. So what I did is I created a blog post just as a kind of a starting point for you. There'll be a bit.ly that will come in here in just a moment. As you can see from all of these links, there's a whole bunch of stuff. If you go to this bit.ly, it's a lot shorter than trying to type in the SCN page. But this will get you going. This is based on what our developers created. That's called the starter kit. And so as you see here, what I'm going to do is I go into log on to the page, and you end up at this at our landing page, at our cockpit. And then what you need to do is you need to go down into services, and this is what we were talking about. Right here you'll start seeing all the services that are available to you right now, and this is on the trial. So you can play with all of these things, learn a bunch of new stuff, and then once you go into here, you go in and you can enable it. Now mine's already enabled, so what I'm going to do is bring in the tutorials that I show, so that way I can at least show you the screenshots of how to do it, so that way I didn't have to create up another account. Basically, you go in here and you just give in your name, your account ID, and then your username and password, and that basically will set it up for you. And then you go down into here, what it will do is create this thing called IoT MMS, and that's the messaging system. And that is actually a Java application. I had little problems finding it. There we go. And that will be enabled right here. And this is kind of looking at all the Java applications that I've created. And so once you're in here, you need to go and create some roles for yourself to assign your user as the account ID, and then actually assign your user so that way they can use it. All right, so that's kind of the admin part of this. It's not terribly exciting, but once you do that, you just have to do it once. Then what you'll see is there'll be a URL here, and this will actually take you to the message management system cockpit. And then you go over here, and this you click this, and this will get you into the actual device management stuff. So the first thing that you need to do is create a device type. As you can see, some of the other ones I've created. You go down here, you push the plus button, and I'm going to give it the ASUG device type, just so that way we can follow, the great name of ASUG device type. This will allow us to follow kind of how these things go through and easily pick them up as we go through. So you just click create, and you'll end up with a ID for this device type that will become very important in a couple minutes when we start sending the data in. So now that we have our device type, and this is just kind of like the overall thing, this might be a forklift or something, or anything like that. Now we need to configure what messages are we going to do. And since we do I've done a lot of demos around agriculture and plants, we're going to kind of do a little bit around temperature and humidity. So that's where you'll see this will come in. So we're going to name this message type, and we're going to have humidity as one of the values, and we're just going to give it a value of a double, as a data type. I think I skip ahead in just a moment. But we'll give in temperature and the brightness, how bright is it outside, how much sunlight is our plants giving. And then we also add in a timestamp. So now that gives us the message type that's linked to that. So that gives us our message type. Now we're actually going to go down to the device. This is the actual individual device, or maybe it's kind of a hub for a set of devices. That's all on how you want to set it up. But this is actually would start talking to one individual device. In my case, it happens to be a Raspberry Pi. I will give you one big hint. When this page clicks up here, grab that token and copy and paste it somewhere. Don't go and use this token. I actually have disabled everything that we did here just because I knew I'd be showing it on the internet, and I don't want everybody sending me a bunch of data for random things. But this was valid when I set it up. So anyway, so now that we have that token ID, that gives us the authorization. That is a unique thing for that device, and it will allow us to send data to and from. And then this ID, this is the actual ID of that device. So now that we have all of this, what we're going to do is we're going to set up, or we're going to go into one of the tools that we have here. We have a simple client that will show you how to just send data, do an HTTP post into it. And as you can see, it is simple, just really nice and easy. That long URL, that is actually how you do the post. And then what you do is go way to the end of it, and you change the device ID from what's there to what you already copied and pasted. So the default here is device 1. We're going to give it this nice long GUID, so that way it's absolutely unique. Then if you follow, I'll copy and paste here in a moment into what our actual payload will look like. And this uses, it's Microsoft's OData is our formatting. And then as you see, the first thing it does is the reason that the post looks like that, what happens is that first time you send it, it creates all the tables. And then the second time you do it, it will actually just give you a response of 200 that it actually worked. So now that we just put in 2 pieces of data in there, just simply the temperature and whatnot. And here is our table right here of showing us how the data comes in. Now, obviously, this is kind of internal tables just to show you that stuff is there and let you see what some of the unique or the device IDs and things like that. So now if we go back into here, we can actually add in some more data and whatnot. I quickly go through this, but one of the value in this is exactly just how you would set this up. You would go in, create your account, create the devices, and then use this tool to kind of test things out, just to make sure that things are working on the server side. What you don't want to do is go and build out all your hardware, do all these things, and do everything at once, because then you don't know, is it an actual hardware failure, like a sensor's not working? Is your code on the hardware device not working? Or is it something like a configuration or error? So what you want to do is break these things up as much as you can into individual steps, and then so that way at least where your bugs are. So as you can see, sending this data through that tool can be a little cumbersome. If you've never used Postman, I highly recommend it. So I use this a lot, and it ends up in most of my demos and stuff. So I kind of just included a little thing here. Postman is just a simple REST client. You can go, it's an extension onto Chrome, so just go and get it. But what it does, what it also allows me to do is show you kind of some of the other parts of this, all those other things that we did. So what you do here is just paste in your ID for that device, and then right in here, this is the code, the content type and the authorization part that you need to send in as part of your request, as part of your HTTP post. I wanted to show you that because a lot of times the tools that simple client tool actually uses your single sign-on or uses cookies and whatnot, so you wouldn't be able to actually know what's going on around that. So anyway, so here we just send in some data, and in this type of demo and this type of quick format, that's about as much as I can really show you of how to do it. The rest of the stuff is a little bit more around, you're going to have to write a little bit of code or follow our tutorial. But what I did do is since I already had this graphing data in there, or this application, this Java application, I can show you how that works. And these are laid out in those things. So this is that other green check mark up there. That is my Java application that handles the UI portion that I'll show you in just a moment. All the code is there in the tutorials. But for this, now you go to this link, and this is the actual outward-facing link for this set of material or set of data. And as you can see, it just does a simple graphing thing. And once again, just to kind of prove to you that we did this and it's real, I just changed the time or the temperature. Unfortunately, when I did this, I actually set the temperature to a value that's too low, so we have to bring it up. And then we'll do it one more time, and that will, you'll see how on this one how fast it comes up. This is in real time. I didn't speed this up or anything. So you hit send, and the data is now already up. Actually, I haven't hit it yet. There we go. We hit send, and now the data is already there, and the screen is already updated. So this can get information in very real time. Just incredibly quick. You can see the data. But now the biggest thing, though, is that as I'm showing here, what you can do is also you can send messages to the device. So in this example that they have for the starter kit, is like you can turn on a light. If it's over 25 degrees Celsius, you turn on the light. And once again, here's the bit.ly. But this shows you the two-way communications you can do through it. You can either do it through an HTTP post kind of system, or we do have WebSockets, and MQTT will be coming up in our next release, or in the next couple months. We'll be able to handle both of those messaging types. Really, it depends on how valuable, how much do you need the device to receive the information, and how fast it needs to happen. So, all right. Now, just to kind of wrap this part up, as we said, here's a bunch of links for that. The nice thing is we also have, after you go through these simple tutorials that I created, then we have a large set of starter kits that go into very detailed. And then Rui actually, about a year ago, started posting his fish import-export business, and this is how to monitor trucks as they go through, to ensure like the cold chain, just to ensure that his fish doesn't go bad. And so he has those examples up there, and that goes into a lot of detail. So this is the main part of the roadmap that we're going for coming up in the next couple of months. Right now we have RDS, and IoT are up here for the application services. Down here for database services, we're adding in Hadoop and streaming. This could be stuff like ESP or basically ESP, the event stream processing, that will be getting up onto the HCP. And just to kind of wrap up, here's a bunch of pages for us that we have just to help you out to get going on stuff. A couple of the nice things is like if you want to go into some really nice deep dives into this at your own pace, you can go into the open SAP courses that Rui has produced. They're very, very high quality. And then, like I said, here's the IoT starter kit. If you want to, and then we've posted, our dev team has posted a lot of code out onto GitHub, although that one happens to be an internal link. So, but we do, if you follow the starter kit, you'll be able to find our external ones too. So, and that pretty much wraps it up from my part. And I think I'll hand this back over to for Q&A. So,
thanks, Aaron and Rui. Appreciate you taking the time today. So we've got some questions to ask in the time we have remaining. One question is, when is this trial available?
The trial itself is available right now. We released it as part of SAPPHIRE, so back in May. So you can do everything we just showed right now. You can go in just a moment, go click over and go build up the account. The IoT services are in beta right now, and they will be as part of the GA towards the end of the year.
Okay, and we'll definitely include the link to the trial information when we push out to attendees. What type of devices can connect?
Really, it depends on you. It's whatever devices are there. Most of the ones that we have are some type of Linux-based. If you're part of the maker movement, so the Raspberry, and you want to do this like on your own in the trial, so stuff like Raspberry Pis are great. A lot of our examples here on campus we build out that way. But it's anything. I mean, we work with industry, so it's a lot of these are these industrial PCs. They just need to be able to send a post So there's a lot of stuff that you can do.
Great. What is the difference between IoT Services and MII Pico?
Well, the MII Pico is what we sell for the plant automation on the actual work or on the plant floor. Because what it is what's the revolution around IoT is that machines and devices have been they've been automated. They've been collecting data for like the last 30 years. But the big difference is those machines were $1 million machines. So you're willing to pay, $10,000 a year for connectivity to make sure that your plant was running. What's different around IoT is that with the connectivity has gotten so cheap and is everywhere, the chips have gotten so cheap and so powerful that now you can, instead of just sensorizing that $1 million machine, now you can do it for a $10,000 machine. Or like these Raspberry Pis are $35, and you can start doing that. But our MII Pico are the established applications that we have for the plants and how they work.
Great. Can we connect from ACP trial account to our on-premise systems?
Oh, yes, you can. So if I may jump in, so you can take so you can take the functionality that I just talked about at the beginning to create this on-premise connectivity. So meaning you create on-premise trusted relationship between what we call the SAP HANA Cloud Connector and your account in the cloud, and with that you can access data both from the cloud, from your devices on the one side, and also from the other side. If you have devices which are running on premise, you can also send their data to the cloud if you want to do that. So that's definitely possible.
Great. Next question. Considering a manufacturing IoT scenario, what architecture would be in place to ensure that there's no latency issues when connecting from devices to the cloud?
Well, one of the things about IoT is it's just about anything can happen, or anything that you want to do, you can do. And it becomes to what is the definition of real time. Because we have a solution with a safety solution around cranes. These are big giant construction cranes, and that's done with SK Solutions. And it has to be on-premise, and this is something we also did with Cisco. And what we do is we build like kind of a mesh net around the work site. And everything in there communicates to a HANA box that's local to there. And so as these cranes move around, if a person walks underneath where they shouldn't be, or two cranes are about to hit each other, the system can come in and stop everybody, and so prevent these accidents. And the nice thing about that, obviously, is if two cranes collide, and especially in places like Dubai where there's like 4 or 5 cranes that can actually literally hit each other, you end up with, killing the number of people and then causing millions of dollars of damage. Our system there has to be real time for that safety thing. So nothing there can connect to the internet. It has to be, fast and everything right at that point. But now if you don't need that type of connectivity, then we can it depends. What we do is the stuff is as fast as the connectivity that will go. We have products from our Sybase colleagues, which is like ESP, which is event stream processing, that can handle the stuff and do that type of thing right there on real time, and then send the important stuff on. Then we have it also. Some of the other products will go through and then do the linking, do the kind of stuff around. To make sure that the databases are in sync, both the local one and the one that's online.
Thanks. Next question here. Is the MMS console the only way to monitor messages, or are there other tools which can be used to monitor messages flowing?
Oh, yeah. No, it's the only one that we've given out. And what it does behind the scenes is just making API calls. So therefore, all this stuff ends up as an API, so if you want something else, you can write it as part of that.
Another way to access this data would be...
Go ahead, Rui.
Yeah, go. Yeah,
go ahead.
Maybe the colleague just wanted to say exactly what I wanted to say. So please go ahead.
So another way to access the data would be that all of this data is stored inside the HANA instance. So you can use the usual tools that we provide with HANA. So for example, the HANA Studio, etc. Just directly query the tables.
Rui, anything to add?
That's exactly what I wanted to say. Yeah, that's exactly what I wanted to say, and which also tried to mention before, meaning that due to the fact that this sensor data lands in your HANA instance in the cloud, you can now use all the technologies and the benefits that HANA brings to you, and run now additional analytics on top of it, right? And trying to create additional value from the data and retrieve insights from the data, maybe by the data itself or by connecting it then with other data coming either also from the same HANA instance or from other systems you are running in the cloud or on premise.
Thanks. Another question here. How do you send the data from real-time sensors other than Raspberry Pi to IoT? At the same time, what are the roles of the API?
How does it? Oh, I mean, really, the device itself to us isn't what's important. Is that you just need to be able to make an HTTP post or make a WebSocket connection. Go ahead, Rui. So,
no,
anyways,
go ahead. Sorry for the latency here. I'm calling from Germany. So the only thing that you need is actually to have the ability to send your data via the internet. And when you send the data, you have with the IoT services you have two modes. So you can send your data in sync mode, right? Meaning synchronously, meaning sending the data, waiting for feedback that it has been stored, and then send the next sender values, or you can send it in asynchronous mode, which means that it just fires the data to your backend system and waits for the response in the function which sees if everything really was stored. So you can do it in two modes, in sync mode or asynchronous mode, which helps you to really also get more data into your account than with synchronous mode. And at the end, it will also depend what kind of bandwidth you want to actually purchase. So we are not yet globally available, right? So the business model is still being discussed, but at the end, it will be a matter of resources that you will be assigning to your IoT service in your account. I hope this helps with the question.
Great, thanks. Next question. I don't see ABAP Stack on HCP. Are there any plans to include ABAP Stack? Now, if I want to build an ABAP-based application on HCP, how can we do that?
I'll let Rui handle that one.
Currently, you cannot run ABAP applications on the HANA Cloud Platform. So we support the 3 runtimes I just explained at the beginning. What you of course can do and use what I've already talked about before, using the maybe your ABAP backend somewhere on premise or another cloud system that you have somewhere else, and connect it with the cloud connector to your account on the HANA Cloud Platform. But currently, we don't support ABAP on the HANA Cloud Platform.
Thanks. Next question. In the trial account, only test HTTP is released. I don't see the API part released. When will it be released?
I'm sorry, can you repeat it?
In the trial account, only test HTTP is released. I don't see the API part released. When will it be released?
Actually, in some of the examples that we give in the tutorials, it shows you how to set up transfer this over to a regular HANA XS engine on HCP. So that's probably would be how you would do it, but I'm a little confused on the question.
Okay. No worries.
Yeah, actually it's the same here. I didn't quite get the question.
So if the person that wrote the question could perhaps explain in a little more detail, and if we don't get it on the call, maybe we can get to it post the call.
Yeah.
Just going through different questions here. I think we've covered, one more question here I see, related to sensor types. Are there SAP recommended sensor manufacturers which go on existing machinery? The work that Siemens does with SAP HANA are for newer machinery from Siemens.
Well,
there are a ton of slap-on sensors out there that can probably just plug in.
Yeah, and we are working with a number of manufacturers. This is, well, actually Siemens happens to, there's a lot of stuff that we're working with in manufacturers to kind of get, to make this process easier for our customers. So like to put a little piece of code that comes in on the manufacturing side. In general, it's basically, as Rui said, anything that can connect to the internet. And I know both Siemens, Schneider Electric in Europe, plus Honeywell, and here basically any sensor that's being manufactured today will have some type of connectivity. And from that, if they have that ability, we'll be able to connect to them. And what we'll need to be is in that project, we'll just work with that partner to do it. In the coming 6 months to 2 years, there will be a number of manufacturers that will start building these devices out with with code actually written already on the devices.
Great. So, okay, so I think we're just winding down and running out of time. I want to thank Rui and Aaron for taking the time today to share this presentation with us. And just as a reminder,
it's a pleasure.
TechEd is the week of October 19th in Las Vegas. We will, on the ASUG pre-conference day, have actually 2 half-day IoT sessions, one in the morning and one in the afternoon. So we'll definitely be sharing more details on that. Plus, there will be a number of IoT sessions that will be embedded throughout the TechEd program. So definitely keep that event on your radar. And I'll just pass it over to Kayla now to wrap us up.
Thank you so very much, Paul, and thank you to our speakers today. On behalf of ASUG, I would like to thank those of you who have been a part of this ongoing series. As Paul said, we launched this initiative at the end of May, and I personally can't believe how fast it's gone. So with that, in addition to the webcast recording and the slide deck, I will also be including links to all of our past recordings. So if you've missed an episode or 2 in this series, then you will have a direct link to go online and give them a listen. On behalf of ASUG and the Internet of Things community, thank you, and we do look forward to the next time. Have a great rest of the day.